Hello everyone, welcome to Figure One. Every week I take the hottest new research paper in AI and then ask my husband Sean to translate it into plain English. So this week we have DeepSeek V4 towards highly efficient million token context intelligence. If you hear the noise in the background, it's our dog, but just ignore it. Okay, so Sean, what is this about?
Yeah, so you guys almost have heard of DeepSeek. It's a Chinese AI lab that has been released a lot good open source models. And then they have released a new version V4 recently, which has two different versions. One is the big one with the 1.6 trillion parameters, and the other one is the smaller one, which is named Flash, with the 284 billion parameters. And then the good thing about this model is that they're able to they make it to handle the very long context, which means that they reduce the memory requirements to run the model, so that it means that you can handle the bigger context size within the same GPU, or handle the more multiple concurrent inputs given the same GPU size. And then we'd like to talk about what kind of innovation that the DeepSeek has made to make the to handle the long context more efficiently compared to the previous models.
Just to be clear, context is kind of the size of the input.
Yeah, exactly. So you may already users of the ChatGPT or Claude must have already have heard of the context. So it means that how many tokens are provided as an input to generate the output, and then most of the models usually have around like a 200 k input size as a maximum context size.
Just to clarify, what is a token? Is each one token corresponding to one word?
So the token can be thought as the minimum size of the information that those language model is processing. It can be thought as like a word, but the word usually consists of the multiple subcomponents. Like preset means it's a composition of a pre and set, right?
Mm-hmm.
So like to model such a things, like the LLM used like a smaller size of the the chunk of characters to represent the information. So those are called token. So basically, the token is like a smaller unit than the word, which the LLM is using to represent the information.
So tokens are the building blocks of the English of language,
Of the
not just English language.
yeah, the input to the LLM is always like tokenized, which basically means that the input words are first like divided, and then based on the what token that each word has, and then those tokens are being used to process the information.
Okay.
Okay.
Okay, we can go into the contribution of DeepSeek in particular in this paper.
Yeah, so this V4 paper, compared to the previous papers, its own contribution can be seen in this compressed sparse attention. And then I think that we have to talk a little bit about what is attention is to understand how the modern days language models works. What language model is doing is that it's generating the output given the input. Then the input usually has multiple tokens, multiple words. Mm-hmm. And then to generate the output, what it has to do is that it needs to know the relationship between the words to generate the output. The language model, what it does is that it calculates all the a relationship between the tokens in the input. So if there is a n number of tokens in the input, then it'll calculate the n by n number of the relationship to represent those. And then to calculate those relationship, there is a computation called attention. Then the attention is it can be thought as calculating the relevance between the consisting tokens of the sentence. For example, I know Harry Potter and he is strong. If the sentence is like that, then one thing that is the information should have is that what is he in this sentence. I mean, he was referring to Harry Potter in this sentence, right? And then there's
But in your example, what is the input? What is the output?
So I mean, let's just assume that the input is just I know I know Harry Potter and he's strong. And then and then we want to like make some like a sequence of number that is representing the input, and then we want to make a sequence of number that represent the sentence, and then what it has to do is that it has to like know the relationship between each of the words. For example, in this sentence, because we have a he in this sentence, the he, we have to know that the he is referring to Harry Potter. Okay. And then how it can know is that you have to like know the relationship between the he and every word, and then you have to figure out the he and then the Harry Potter as the strongest connection compared to the others. And then how you know this like connection strength is some mechanism called the attention.
Okay, so the requirement is usually like we have to calculate each word with the relationship between each word with the rest of the words.
Yeah. So like for each of the words, you have to calculate the relevance of the like all the other words. The next word also have to calculate the relationship with all the other words. So that's why it's n by n. If there's
okay,
n.
So that's why it sounds like it's a really heavy job.
Yeah. So what the DeepSeek has been done is that in the previous paper they suggested the method called sparse attention.
Okay.
So what sparse attention means is that let's assume that the input is the whole Harry Potter series, and then there was a question: who is the father of Harry Potter, for example? Then if it's like just a regular, like a naive language model, what it has to do is that you have to then get the relationship between this who is the father of the Harry Potter with all the sentences, all the single words in the whole Harry Potter series, right?
Okay.
But what the sparse attention do is that you don't want to go over all the sentences. You want to first select some like a relevant sentence first, and then look into the relationship between those sentences, and then this question sentence, like who is the father of Harry Potter. So then the question will be how to select the relevant sentences.
Yeah,
and
then what I was gonna ask.
Yeah, then it should be like done like quickly. So it's like it's using the same mechanism of like going over all the sentences and then calculating the relationship. But rather than using the regular attention, which involves some complex the calculation, it uses the much like a lighter calculation, but still can calculate the relevance between the who is the father of the Harry Potter and then each of the sentences. And then after that, you get the numbers of the relevance, and then you just select like a top like k number of the like sentences to look into more precisely. So it can be thought as like you just first skim over all the sentences, and then you just look into the sentence that has like something like a father Harry Potter. Then just like select look into those sentences and just gather those sentences, and then so they
find a way to kind of represent each sentence in a compact way somehow, so you can skim through them.
Yeah. So like there is each of the sentences are already represented in a compact way, but the point is that like the relevance between the like relevance calculation mechanism is simpler.
Okay. Could the sparse attention be thought of as more of it's a level of abstraction? So abstracting each sentence into something higher level, right? Smaller than the actual content.
Not in this case. So it's like right now sparse attention is like just there's no abstraction, but you're still looking into each of the sentences one by one, but select the subset of the sentence and then do the looking into the relevance with the subset of the sentences. But thus like abstraction is actually is related to the compression in this DeepSeek.
Okay.
So I'm going to talk about the compression. So what it does is that it can be thought as Harry Potter, there are 7 books in the series, and then the compression can be seen as that you are building a like a summary of each of the book. I mean, so you are not looking into you don't want to look into all the sentences in the series. You want to build the one sentence for each of the book.
Okay.
And then after building the one sentence, then there will be only 7 sentences from the thousands of the of the sentences, right? And then you calculate the relevance relationship between the who is the father of the Harry Potters with only the 7 sentences.
Okay.
And then so like you are making kind of a summary of the multiple sentences, and then looking into the relationship.
So
and
it's
then,
so the compressed sparse tension. The compressed part is introducing a level of abstraction, or like
Yeah.
introducing a higher hierarchy
Yeah.
of information.
Yeah.
So you can locate, maybe filter out the unnecessary chunks of information first, and then look into the selected.
So I mean, at the beginning, it cannot be seen as like a filtering out the unnecessary information, but like it's like trying to like compress the trying to compress, but like it will like it'll be like not a lossless. I mean, it'll lose some information,
Okay.
but it'll trying to like represent the same information with the smaller number of the smaller number of the numbers.
Okay.
So, so like how does it do is that the DeepSeek V4 combine this like compressing, those like abstracting with the sparse attention. So first step, what it does is that it first make the one sentence for each of the book. If you keep using the Harry Potter, so make the 7 sentences, and then do the sparse attention over the 7 sentences. So like they choose the most relevant book among related to the question who is the father of the Harry Potter. Then it'll be like, so it'll choose like a subset of the books, right? Mostly likely like the first book, because the story, the family of Harry Potter was talking the first book. And then let's assume that then there were like 2 sentences were selected. And then and after that the 2 sentences are selected, the relationship between the who is the father of the Harry Potter and then those like 2 books will be calculated, and then make the final output.
Okay.
Yeah. So that is the compressed sparse attention. And then the DeepSeek V4 compared to the V3 or previous model is that actually the sparse attention, like selecting the subset of the sentences, was already presented in the previous paper. But those compression part, like making the summary of each of the book, is the V4 specific. And then that's how actually they were able to like reduce the memory requirement to calculate the output, because like before you can be thought as like you had to like had all the information about each of the sentences in the memory. Right now you only have to have a sentence that representing each of the book in the memory, so it's like
so less requirement on the memory,
less memory requirements.
Okay.
Yeah.
But just to be honest, I feel like most of the things we talked about so far, I'm sure all of the other big players in AI are doing the same, trying to do the same thing. But sounds like DeepSeek is leading the pack in a way.
Oh yes.
Okay.
Why always like DeepSeek's model has been under the focus is that in the previous paper, like V3 or R1 paper, they have suggested like a totally different way of making the model to do the reasoning by using the much easier way than the previous way of making the model to do reasoning. The previous way before that was that we needed at least like some sort of like a warm starting, which means that we need some like a training data that contains about how to reason.
Okay.
So
by reasoning, you mean like those chunks of middle steps before ChatGPT tells me the final answer.
Yeah. So when you use the ChatGPT or Claude, you see that it does like some thinking before you return your final output. Like, and then those like step-by-step process to make the model to do previously. We first had to like build like a training data that has for each of the like question, it has the like step-by-step chain of thoughts, and then to make the model to learn it directly from the training data, and then later people use something called reinforcement learning, which is like making the model to solve the like a questions by itself and giving them the like a scholar feedback whether the answer was correct or not.
Okay.
So what DeepSeek has done is that by changing the reinforcement learning the algorithm, they removed the requirement to use the training data at the beginning. So like from the start, they showed that we could use the RL reinforcement learning to make the model to do the reasoning, will bring the cost to train the model much lower because we don't have to build the training data.
So training data, you meant like the full reasoning, data with full reasoning,
Yeah.
and to know whether one is better than the other. One reasoning is better than the other.
Oh yeah,
something
yes,
like that.
yep.
So, but then DeepSeek is saying you don't need to do this.
Yeah,
We only just need to know whether the outcome is correct or not,
yeah, for the given input.
which is a lot easier
Yep,
to obtain.
Mhm.
Okay. Okay, so what is the takeaway for today?
The takeaway today is that DeepSeek V4's proposals like kind of innovative way to reduce the memory requirements to running the language model, which is cool. So and then I'm kind of looking forward to see what kind of innovation that they would make in the future because like every time they release a new model, always they give us some like a quite detailed technical reports that detail about their like a new algorithm, and then every time is quite like interesting to see. So as a researcher, yeah, like I'm really happy that the DeepSeeks are like kind of very open about their own new innovation.
Okay. I guess that's it for today. What do you guys think? Did Sean do a good job explaining the paper? Don't forget to like and subscribe.